Welcome. This video is going to start taking a look at the Chapter 9 study guide, looking specifically at objective number 1. And I'm going to break this down into 3 parts. It says, given a word statement, be able to write a skeleton equation and or a balanced equation. And before we do a skeleton and then a balanced equation, I want to start with reviewing the 4 types of substances you should be able to write the correct equation for, or formula for, I should say. We have metals, nonmetals, ionic compounds, and covalent compounds. And it's pretty simple to tell the difference in them. If it's an element, a metal or a nonmetal, there's only a single part to the name. So bromine gas, only bromine indicates what's in it. Gas really isn't telling me anything. So there's just a single part to the name. Solid ruthenium, again, just the ruthenium is telling me about what's in that particular substance. And then I have dihydrogen dioxide. That has 2 things in it, hydrogen and oxygen both, and platinum oxide. So when I look at these 4 substances, I know the first 2 are elements, either metals or nonmetals, and the second 2 are compounds, either ionic or covalent. So looking at bromine, I see that it's a nonmetal, and nonmetals are tiny, and because they're tiny, they have high electronegativity, and they're attracted even to themselves. So I think of nonmetals as being tiny 2s, or Br2 would be the correct formula. Solid ruthenium, on the other hand, is a metal, and as I try and find it on here, I see that its symbol is Ru, and metals being large, they are large and lonely and come just by themselves, just Ru. So nonmetals come in 2s, metals in 1. Then looking at my 2 compounds, dihydrogen dioxide, hydrogen and oxygen are both nonmetals, so I know this is a covalent compound, and I know there should be prefixes telling me what my formula is. So dihydrogen is telling me 2 hydrogen, dioxide is telling me 2 oxygen, so this would be H2O2. Platinum oxide is a metal and a nonmetal, so I have to figure out how many electrons the metal is losing and how many electrons the nonmetal can gain. So the 3 here is telling me that platinum, which is a transition metal, is giving up 3 electrons in this case. Each platinum atom will donate 2 or 3 electrons. Oxygen, being in a family 6, always takes 2, so 1 to 1 is not enough. When I bring in a second oxygen, now I come up short an electron, so I have to bring in another platinum. Well, now, of course, I'm going to need another oxygen. So to lose 6 electrons and have oxygen gain 6 electrons would take 2 platinum and 3 oxygen, or Pt2O3 would be the correct formula. So then using this information, we're going to use this same set of rules to go ahead and write a skeleton equation for the following reaction. Lithium metal, so it tells you right there it's a metal, just going to be large and lonely, or Li, is placed in a solution of iron 3 sulfate. So iron's losing 3. If I look up sulfate, sulfate's SO4, and it needs to gain 2. So you maybe recognize this, we just did a similar one. 2 sulfate, now suddenly I have too many electrons being needed. Bring in another iron, another sulfate, and the correct formula is Fe2SO4 parentheses 3. And in this particular case, I didn't tell you what the products are, and you're not going to be expected to predict the products on the test, although you will on your mastery. But what I see here is that it's a single replacement reaction. So what I know is that metals can replace metals. If lithium is more reactive than iron, it can replace it in this equation. But metals never replace nonmetals. So since I'm being told the reaction happens, I would expect lithium and sulfate to bond. Lithium has just 1 electron to give up. Sulfate needs 2. So I see I'm going to need 2 lithium for 1 sulfate, or Li2SO4, and then iron will be by itself, large and lonely, or just Fe. And let me just redraw this a little better for you in case you're not understanding this. Lithium has 1 electron to give up. Sulfate needs 2 electrons. So 1 sulfate would need to bond with 2 lithium, or Li2SO4. So then the third step is, once we have the correct skeleton equation, is to balance this. I can't have 2 Fe on the reactant side and only 1 Fe on the product side. Same with my sulfate. So as far as the balancing, I'm going to go on to the next slide here and show you how to use a RAP table. So the idea with a RAP table or a RAP sheet is that you list the atoms, the different elements, or the ions, so Li, Fe, and I'm going to list SO4 as one thing because it stays together on both sides. It's just a sulfate ion. I have 1 on the reactant side, 2 iron, and 3 sulfate. And on the product side, I have 2 lithium, 1 iron, and just 1 sulfate. So the idea with minnow is it tells you what order to try and balance things in. So usually you balance your metals, then your ions, then your nonmetals, and save oxygen and hydrogen until last. So I'll start with lithium since it's the first metal listed and put a 2 here. So that looks good. Iron, I need more on the product side, so I put a 2 here. And remember, I can only put the 2 in front because if I change the subscript, that changes the substance. Then I get to sulfate. Well, sulfate, I need 3, so I'd have to put a 3 here, which is great for the sulfate, but that changes my lithium to 6. So now my lithium is messed up, and I'm going to have to go back and change this to a 6 as well. And that's not so unusual that you have to double back and balance things more than once. But again, balance this pretty easily. And this is the main skill you need to be able to do on your Chapter 9 test.